Good day, everybody. So this one video is for 5.5 first differences. This is the last lesson second last lesson of the chapter. The next one to finish the chapter I'll do next week, and that will wrap up chapter 5. The last one next week will also cover everything that we just did in this chapter and kind of summarize it all together. Okay, so this one's a fairly easy lesson, first differences, but this lesson is going to be applicable for grade 9, grade 10, grade 11, grade 12. So you're going to see this for the rest of your math career, I guess you want to say, for high school. Okay, so first differences. So first being first, and then differences. So differences in math, if you recall, means subtraction. So we're doing our first subtractions. Okay, so number one, calculate the first differences of the following tables, and then ask, are the relations linear or nonlinear? Okay, so this is how it works. We're going to start with the bottom value. Okay, so we're going to take the bottom value and then subtract the value above it. So we're going to take the bottom value, which is 12, and we're going to subtract the number above it, which is 9. Okay, then we take 9 again, and we subtract the number above it, which is 6. Then we take, 6. So 12 minus 9, 9 minus 6, now 6 minus 3, and lastly 3 minus 0. So 12 minus 9, 9 minus 6, 6 minus 3, and 3 minus 0 all equal positive 3. Okay, so that's first differences, first subtractions. When you get to grade 10, you'll do your second differences, which is second subtractions. And then in grade 11, you'll do ratios and third differences. And then grade 12, you expand on that with finite differences. Okay, so we have 3. I'll explain what this means after we finish all the tables. Okay, next one. Again, start at the bottom. So -9 minus a -5. So -9 subtract -5. Okay, then we take the -5 again, a -5. So -5 subtract -1. Then we keep going, -1 subtract positive 3. And then 3 subtract 7. So again, start from the bottom, subtract the one above it, take that value, subtract the one above it, take that value, subtract the one above it, take that number, and subtract above it. So here we have -9 subtract a -5. Okay, so you notice here that we have 2 negatives here. So what happens when we have a subtract a negative or 2 negatives? Well, it becomes positive. Okay, so we have a -9 plus 5. So 9 negatives, 5 positives gives you -4. Okay, over here, -5 subtract a -1. Again, 2 negatives gives you a positive. So we have -5 plus 1, which is also, let me erase this, which is also -4. Then we have -3, subtract +3, so -1 minus 3, -4, and then 3 minus 7 is -4 as well. Okay, so for the first one, we got all positive 3s. Second one, we get all -4s. Okay, and now we're going to do our last one here. So again, 17, subtract the number above it, which is 9. Then 9, subtract 3. 3, subtract a -1. And lastly, a -1 minus a -3. So 17 minus 9, 8. 9 minus 3 6. 3 minus a negative 1, so 3 plus 1 is 4. And negative 1 plus 3 is positive 2. Okay, so what does this all mean? Okay, if the numbers are all the same, whether it is positive or negative, then it is considered a linear relationship. It's perfectly linear. All these values are going up by 3. All these ones are going down by 4. Okay, so that means it's perfectly linear. So this means if the first differences are the same, which is the case in the first one and the second one, then it is a linear relationship. Okay, if the first differences are not the same, then it's supposed to be then there is a non-linear, that means there is a non-linear relationship, which is this one here. Okay, so the first two tables, first differences are the same. That means these two are linear. The third one, the first differences are different. They're not the same number. That means it's non-linear. Okay. A key thing here, I put a bold in the lesson. In order for you to do this first differences, so in order for you to do it for every one, the x values must be going up by the same amount, be increasing by a constant amount. That means the x values must be going up in the same amount. So here you'll see that our x values are going up by 1, so we're allowed to do the first differences. Over here, the x values are going up by 2s, so you're allowed to do the first differences. And the same here, our x values are going up by 1, so we're allowed to do the first differences. If these x values are not going up by the same amount, you cannot do the first differences. Okay, and most, I believe in all the homework, they will be going up by the same amount, but in the past, I know the EQAO, often they don't go up by the same amount. They try to trick you. So in order to do first differences, they must be going up by the same amount. Okay, I wanted to go through one of the homework questions before I assign the full work. So I wanted to go through page 275, page 275, number 1. Okay, so page 275, number 1, it says, look at each equation and predict whether it represents a linear relation or a non-linear relation. Okay, you don't have a graphing calculator, so don't worry about this. Okay, so first one, this is y equals mx plus b, linear. So I'm going to put an L here for linear. B, y equals mx plus b. So when I mean mx plus b, it's what we learned with partial variation. So y equals 5x plus 6. This is linear. Next one, y equals negative 3x minus 2. This is also linear. Okay, linear, linear. And I'll tell you why afterwards. This one here has a square. It has an exponent in here. So this one is non-linear. Okay, non-linear. Okay, D, the x is in the exponent. This is also non-linear. Okay, next one. Y equals negative 4/3, which is 1.3. So negative 1.3x plus a half. Okay, this one is linear. That's y equals mx plus b. And lastly, we have the x in the denominator. This one is non-linear. Okay, so how do we know when it is linear or not? So these are the general rules. If, I'll write it over here, the x and y if you look at all the x's and y's here, they all have the same, the ones that are linear have the same exponents. Okay, so y, all the y's are the same, but here the x has an exponent 1, the x over here has an exponent 1, and the equation here, the x has an exponent 1. So for linear, x and y must have an exponent of 1. Okay, must have an exponent of 1. Okay, so that would take out this one, because that's a square that has an exponent 2, so that's nonlinear right away. Okay, over here, the x is in the exponent. So if it's in the exponent, then it's not linear. Okay, and then here, the x is in the denominator. It has a power of 1, but it's in the denominator, so this is not linear as well. So in the equations, if x is in like a weird spot, so like if it's not in the numerator, so all these x's are in the numerator here, so a, b, and e, the x is in the numerator, then it works. So x must be in the numerator. Okay, must be in the numerator. And that goes with y as well. Okay, here the x is in the exponent, so that's not the numerator. And here the x is in the denominator. Okay, in just general, if it looks funny, it's chances it's not linear. So squared, power, or in the denominator. The only other situation you may come across is something like this. So y equals the square root of x. So x is in the numerator here. Okay, it looks pretty good, but it has this square root sign. So this one would be non-linear as well. Okay, so you have to do the rest of the questions for homework. So that would be page 276, number 2, 3, and 4, 6, and 9. Okay, page 276, 2 to 4, so 2, 3, 4, 6, and 9. Okay, that concludes the lessons for the week. I hope everyone has a wonderful weekend, and if you have any questions, feel free to email me, and if not, we will start the last lesson next week. Have a good day, everyone. Take care. Bye.